Alright, in this video we're going to talk about cryptography, which is coding and encoding messages. And we're going to use matrices to do that. More specifically, cryptography is a method of using advanced mathematical principles, so we're going to use matrices in this video, in storing and transmitting data in a particular form so that only those for whom it's intended for can read and process it. Cryptography has been used for a long time, thousands and thousands of years, by people who relay messages without detection. So you can think like World War II, the Enigma machine. Any wars, people are going to be passing messages messages to each other. Or maybe if you have your own secret language with your friend that only you and your friend understand. Right? That's a form of cryptography. The earliest use of cryptography was seen in the tomb taken from the Old Kingdom in Egypt about 2,000 years before Christ existed. It's a critical tool in encryption, is the most critical tool in cryptography, and that is the means by which a message can be made unreadable for an unintended reader and can only be read by the sender and the recipient. Right? It's also used a lot in coding on the internet. When computers send messages back and forth to each other, it's encrypted, so if a third party intercepts it, they're not able to interpret that information. That's what encryption means. Alright, so the way we're going to do it, step one, we need to involve numbers. So we're going to assign these letters to the following numbers. So the position in the alphabet corresponds to the number. So A is 1, B is 2, so on and so forth. And for spaces, we're going to use 0. Now, think for yourself, why can't we just leave spaces? Why do we need a number for spaces? Pause the video and think about that for a second. Alright, so this might make more sense once we do more of this, but you wouldn't want to have like a 3-letter word and a 4-letter word and a 5-letter word with spaces in between, because then if you know the number of letters per word, it becomes a lot easier to encrypt or decode your message. So you want to give away as little information as possible. So that's why a space you want to treat just like any other letter. Alright, so step 2, we're going to write the uncoated row in 1x3 matrices. Now, you could do 1x3, especially if you have a calculator. You can really do 1x4, but I wouldn't advise that. I'll also show you to do 1x2, but you're going to want one row for your message, and the number of columns will correspond with the columns and rows of your key. So you'll see what I mean in a second. So if we're going to use 1x3 matrices, we're going to use a 3x3 square matrix as our key. So the key unlocks or locks our code, like decodes and uncodes it, and you'll see what I mean. Alright, so step 2 is rewrite the uncoded row in letters. So hello would be 8, 5, 12, 12, 15, 0, because each letter corresponds with those numbers. Now, if you're trying to decode this, a good trick is to look for repeated letters, repeated numbers. So you see that 12 and 12 are repeated. So if you were trying to figure out what 8, 5, 12, 12, 15, 0 meant, the 12 and 12 would be a help. You know that you'd have to look for words that have double letters in the middle of it. Alright, just a little tip or trick if you're ever encrypting or uncoding something yourself. Alright, then we need to choose a square matrix that's going to be our encoding matrix. I like to call it the key or the lock. Alright, now we're going to use a 3x3 matrix because, remember, our message is written in 1x3 matrices, so it has to be able to multiply to those matrices. Now the key matrix could be anything. That's just a random square matrix that C is right there in the top. So you could have made any letters, any numbers there, but you want it to be random, so that's hard to guess. Alright, so that's what you need to either code or uncode it. Alright, and step 4 is simply we're going to multiply each of the 1x3 matrices by the encoding matrix, and what we get is now the encrypted code. Alright, so now if you saw this, you would have without the key, you would have no idea what that meant. But if you had the key, you can then decode it and get back to the original matrix and then figure out what the message was saying. Okay, so here's another example that you could do without a calculator. Right, so this previous example, you need a calculator. I guess you don't really need a calculator. You could multiply these together by hand and get that, but it takes some time, so I encourage you to use a calculator. And if you don't have a calculator, just use 1 by 2 matrices. So I'll show you what I mean, and we'll do this example in the next video.